So this is an experiment to test processes that should happen in protoplanetary disks, where small particles of dust are floating inside a gas at low pressure, and we are looking at some aerodynamics aspects of this interaction between the gas and the dust. And these are things we do normally in the lab, but here for the first time we'll be able to do it without the effect of gravity. And so these processes are important because they are key in our models of formation of planetary systems. They are key to understand how we go from a phase where the dust is in micrometric particles in the disk up to centimetric size pebbles, and then up to the size of kilometers of planetesimals. So here we are testing some key aspects of the process that play a role in this growing of the dust toward planetesimals. One thing which is special about some of the experiments we will do is that we don't only use the 0g phase, but we also use the hypergravity phase, during which we have 2g of acceleration, so 2 times more than normally on the ground. So we are using both phases. So we are actually looking at 40 seconds up to 1 minute of interesting data acquisition. We had only 6 months to build this thing, but actually the most challenging part was that we had the COVID pandemics in the middle. So for 2 months we were only able to work on a reduced space, and we had no access to the lab, so that was the most difficult part for us. So we had to reduce a bit our ambitions in some aspects of the experiment. So some of the things we will do today in the flight will be only tests, and then we will have another flight campaign later on where we will do the entire experiments. Are you ready?
Trying to connect.
Yeah, you can make up maybe we can
disable it. So this is the TEMPus VoLA experiment, the timed Epstein multi-pressure vessel at low accelerations. So what this means is that there's multiple pressure vessels. You can see inside that we have 5 different chambers, and with particles seated in them. And we pump down the system with a vacuum pump, and so we reach low pressure conditions, and this brings us into the so-called Epstein drag regime. And of course, when we go on our parabola, we'll be at low accelerations. We'll alternate between high and low accelerations. And because of this variation in gravity, the timing is very important for us. So we have a principal timing unit here that controls the clock rate of the cameras, and when we trigger it with a light source, it's also outside here. And we also have a control center over here with a computer for a second camera, and this is how we gauge the pressure. And the 2 operators will be seated here and here, and one will be responsible for controlling the flow rate and setting the pressure, and the other one will be flipping the valves and taking care of the high-speed camera and the timing unit over here. Of course, usually after you build something, you have a commissioning and testing phase. So we managed to build it, and we had a very short testing phase. So this is one of our first tests.
Ja, das Einbauen morgen in den Flieger war noch ein bisschen spannend. Also, es war eine Millimeterarbeit unter dem Strich. Also, wir hatten Millimeter zu viel und zu breit. Aber wir haben es dann irgendwie reingebracht. Es war wirklich eigentlich eine Punktlandung im Endeffekt, auch schon die ganze Woche hier.
to go through it a bit carefully because right now we just have like a couple of movies we can look at, which it's great because we saw at least that the experiment did what we wanted it to do. The particles that we have at the bottom gets like to a fluid state and then go around the chamber following I guess the movement of the plane. So we need to really look at exactly how the flow through the chambers affects this, or the particles move, and all the different types of particles actually kind of differ in terms of their movement. But I said, like, yeah, it's great that we have these images and this worked. It's amazing. Working on the experiment doing zero-G we didn't have much to do during that phase because we were mostly doing image acquisitions. We would start it before the hyper-G phase when we just go up. And the hyper-G phase was much more intense than I expected. Like you really feel much heavier. You can see.
My day was very eventful. It started quite early. We were here before 7, and we had the flight preparations with the medical review and safety review, and then we were ready for the flight. And yeah, it was exciting, and it was a completely new experience, and it was very exciting to see our experiment in action. Where I was seated was right in front of the window where I could actually see the particles in our experiment levitate, and so that was really exciting because this is a new experiment and we took it from design to realization, and that's always the most exciting thing, is to see your kind of vision come to life, and it came to life today, so that was pretty amazing. And then on top of it, to be in this this kind of unusual environment and experience weightlessness was, yeah, it was all pretty great.